Hi everybody, today we're going to have a look at turning point form. It's the third of the forms that we've been looking at. We've already looked at standard form and factored form. So the features of a turning point form and what it looks like, well, here's the equation. It goes y equals a x take p all squared plus q, where p and q is the turning point of the function, remembering that we have to change the sign of whatever's here. The line of symmetry is simply x equals p. And the y-intercept, well, if we substitute 0 into whatever this equation is, and write it as 0, comma, the solution, we will have the y-intercept. But what we're notably missing here is the x-intercept. So we're going to look at a method for finding the x-intercepts as well. Let's have a look at a quick example without the x-intercept. By just looking at the equation, we know that the turning point's at 2, 3. Easy enough. We know the line of symmetry is at x equals 2. The same way that we've known the line of symmetry for the other functions as soon as we know the turning point. And the y-intercept, substituting 0 into here, 0 take 2 is 4, 0 take 2 is negative 2, all squared is 4, plus 3 is 7. And that's where that comes from. Now, for the x-intercepts. What we're going to have a look at first is the general form of a turning point equation. That's this over here. And we're going to rearrange it so that we have x on one side of the equation. To do that, we need to recognize that the x-intercepts always occur where y equals 0. So we're going to place 0 where y is, which I've done here. Then we're going to subtract q from both sides, which I've done here. Then we're going to divide both sides by a, which I've done here. Then we're going to take the square root of both sides, remembering that when we do so, we're going to end up with two solutions, a positive and a negative one, which is what we've done here. And then we add p to both sides. And we get this equation. Now when we get this equation, we can see that we end up with a value of p, which we know is the line of symmetry from earlier, at plus or minus a value. And that value is the distance from the line of symmetry where the x-intercepts live. That's all I've said here. So let's look at an example. If y equals x take 4 all squared take 3, and we want to find the x-intercepts, or the roots, we substitute 0 in for y, because when y is 0, that's where we find the corresponding points. Add 3 to both sides. Take the square root of both sides, remembering to have both the positive and the negative solution. Add 4 to both sides, and we can now see that the x-intercepts are at 4 plus or minus root 3. So here's 4. Minus root 3 would be to here, plus root 3 would be to here. And that's all I've written here. I could find out the decimal values of it, but that's sufficient for what I'm trying to show. The line of symmetry will be at x equals 4. That's what it's symmetrical about. The turning point's at 4, negative 3. We know that from turning point form, as we knew the line of symmetry from turning point form. And if we sub 0 into this equation, which I've done here, we'll find out that the y-intercept's at 0, 13. Of the three forms, factored form, standard form, and turning point form, if you have an equation in turning point form, it is the easiest to work with because most of the information you need you can read straight off the equation itself or the function itself. You can move from standard form to turning point form by completing the square, but it's not covered in this part of the course. So there is actually a video on that elsewhere in the playlist if you're interested. And I think that's all I want to cover in this. Thank you, everyone.